This is number 4 on page 57. So we want to find an equation that has an x and y in there that shows a configuration of all the points that are 5 units from 0, 0. So let's just start with, somebody give me a point that is 5 units from 0, 0. Yes?
5, 0.
5, 0. Really easy one right there. Okay. Do red here. All right, another one. Yes?
Were we supposed to write all of them down?
No, just write this.
I just wrote 7.
Okay, well, just give me one more.
Oh, 5, 0.
I got that one.
Oh, 0, 5.
0, 5. Okay, another one. Yes, Shay.
Negative 5, 0.
Negative 5, 0. Yes.
3, 2.
3, 2. Why would...
Wait, 3, 4.
3, 4. How do you know that 3, 4 is 5 units from 0, 0?
Makes a 3, 4, 5 right triangle.
Right, because we have this triangle here. This has to be 5 because we have a 3 here and a 4 here. So we have a 3, 4, 5 right triangle right there. Another one. Yes? Negative 3, 4. Seeing some symmetry here. Amanda?
4, 3.
Yeah.
4, 3. And everybody sees the pattern here. Yes, Maddie? 0, negative 5. Okay, everybody seeing the pattern here?
Yeah.
So we can kind of go around this.
They're making a circle.
And yes, we are making a circle. That's a configuration of this. So there are our lattice points. So that should answer your question of how many are lattice points. So we have, what, 1, 2, 3, 12. 12 lattice points. And this is called a circle. Okay, and if I really draw this, probably not very well, but I'll try. I missed that one. Missed the one on the right, but not too bad. Okay, now we want an equation for the circle. Now we talked about last week that if I was going to say, let's zoom in on the circle a little bit. And I want to find this equation from here to here, that we could use a distance formula. Now, even though I know that point right there is 4, 3, if I called it x, y, okay, and then just imagine that being anywhere on this circle. Maybe it's not a lattice point that we know of. Okay, so if I call that x, y, then I could do a distance formula from 0, 0 to x, y, because I know that distance is 5. So we're kind of doing like using the distance formula inside out here. Instead of giving 2 points and finding the distance, we're given the distance in 1 point and asked to write an equation. So if we use our usual distance formula, I won't say our usual, I'm going to adjust it a little bit. Usually our distance formula has a square root in it. But if you just think of taking a difference in our x's, squaring it, a difference in our y's, square it. And then usually I take the square root of that to find my distance. But instead I'm going to do my distance squared. So just Pythagorean theorem. And that'll give you your equation for this circle. And I'll get my final equation here would be x squared plus y squared equals 25, and we're done. Any questions there? So usually that's what it looks like. Notice that since we have a minus 0 here, we have zeros here, that those are going to cancel out in our equation, and we're going to get 25 there. Okay, so number 11 here, what do we get for A? We want a circle whose center is at the origin and whose radius is A13. X squared plus y squared equals 169. B. What do we have for that one?
X squared plus 1 squared plus 36.
Copy.
I did not, I did it.
And then C.
X squared plus y squared equals r squared.
That's exactly what I did.
Easy enough.